Midland Heart are one of the largest housing associations that solely concentrates on the Midlands. We have around 35,000 homes and we provide landlord services to over 70,000 tenants. Project 80 is Midland Heart's interpretation of the new Future Homes Standards. So this is our ability to demonstrate that we can build to the government's Future Home Standards today. In fact, actually yesterday, because they haven't even started yet. The Future Home Standard doesn't actually kick in until 2025. But here you are, you can see it. We've already built these homes and people are living in them already.
So the idea of this project was to meet and exceed the incoming Future Home Standard. The standard is part of a regulation change which will be pushed through the Future Homes Hub that will improve the operational carbon or your energy bills of properties in the UK.
So first development is called Eco Drive, which is 12 family homes in Handsworth in Birmingham. And on those we've delivered an 80% CO2 emission reduction compared to 2013 regulations. The second scheme is called Elvetham Road and that's in Edgbaston, and those are 12 maisonettes where we're looking at different solutions to delivering the Future Home Standard. We partner with Birmingham City University and we've been looking at the whole process from end to end. We started off by looking at the tender process, the costing process, and that really relied on the contractor and ourselves providing data to BCU so they can impartially assess it.
We originally tendered the project under a traditional contract tender to be traditionally built to current regulations. Upon award of the contract, Midland Heart gave us a task of trying to achieve Future Home Standard with the building, to convert the building so that they produced 80% less carbon emissions. It involved 3 different specifications of houses, all of which had to be coordinated and double checked to ensure that the Future Home Standard was achieved.
We love the way that the client's involved from the early stage because, of course, all steering really should be from the client. And to have that vision that they have where they really want to produce some brilliant buildings, but of course meeting the Future Home Standard and involving all of the tenants fully as well, that's something that's really close to our hearts.
So from a masonry point of view, there are a number of organisations who are positioning the Future Home Standard as a MMC standard, whereas what we've shown is that you can still use masonry to achieve or satisfy the Future Home Standard. And the reason we chose masonry for this project is that masonry is the most prevalent form of construction in the UK house building industry, and it means that our contractors don't need to deviate from what they're used to. So from a masonry point of view, the main difference was the external wall construction. So we worked with H+H and BES block and Unilin insulation, and we came up with a solution that gave us a U value of 0.13. So that's a 100 mil of block, 150 mil of PIR insulation, and then 100 mil of brickwork.
Well, it's critical for us in our research and development plan and our aspirations for the future, and we're lucky to have partners in Midland Heart and in Tricast Construction. I think having an amalgamation of people that are like-minded on the same journey is really important for us to achieve a full Future Home Standard.
Well, from inception, we were involved on supply of materials and also on the technical side as to what solutions would meet the right U values for this project. We understand that aiming for the Future Home Standard is very, very important to all house builders and those involved in construction.
It wouldn't be possible to achieve a regulation change of this enormity without going back to basics and looking at all the producers, all the manufacturers, taking their knowledge and injecting it into this project so that you can achieve that standard.
And it's really important for us to be able to work closely with our supply chains and our trade bodies to be able to not only demonstrate that this works, but the ability to disseminate this across the supply chain so we can actually continue to permeate this across the sector.
When we got to the actual occupation stage, we've got sensors in all of these properties. So we've got sensors that monitor the energy use on an individual circuit level. So we can look at how much sockets are using, for example, how much the heat pump's using, and that tells us kind of real-time data so we can understand the energy performance of the properties. We've got things like external wall U values of 0.13, we've got roof U values of 0.1, floor U values of 0.11. We normally have a window with a U value of 1.4, these are now 1.2. And we've also decided to test different levels of air tightness on these properties. So some of the air tightness of the properties are down as low as 2, which is very low, which means we require a mechanical ventilation system. And the others are 5, and that allows us to look at a natural ventilation system. Other things we've done are look at different ways of producing space heating and hot water. So we've used air source heat pumps in a number of the plots, again to understand how they work and how our residents interact with them. And on other plots we've used panel heaters for space heating because they mimic how people would use the gas boiler as closely as an electrical system would. And also we've used a hot water heat pump for hot water generation.
These masonry constructions are key to keeping things like that in check. The overheating aspect, if you look at things like dynamic thermal modelling, comes a lot better when you look at heavyweight builds. It can be anything up to 2 degrees better during an overheating event, which bleeds into things like comfort for residents and users. It's going to mean that they are a lot more satisfactory properties for these people to own. Improvements in U values, in wall values, is going to mean that temperature is a lot more stable during cold periods and hot periods. It's going to be super critical that they deliver a better satisfactory comfort of living for all residents.
So some of our residents in 3-bedroom properties, for example, throughout the year, they're spending £1,200 on all of their bills.
So part of what we talk about a lot as a trade association, especially representing the masonry members within the UK housing industry, we talk about robustness and durability of construction. These properties are heavyweight masonry builds. They're going to be here for a very long time. We talk about design lives of 100-year plus, and it's a durability aspect of that. These houses can be modified at a later date or, to all intents and purposes, left as they are, and they will operate during that period as efficiently as we expect them to do so.
So the data that's been generated has already kind of informed our thinking, so we've decided as an organisation that we're going to adopt our Future Homes Fabric as standard.
Ultimately, we have an opportunity to demonstrate not only can we actually ensure that we build homes at a reduced carbon footprint, but just as vitally that we can help reduce fuel bills as well. So from our perspective, what we want to do is be in a position that we can demonstrate to the supply chain and the housing sector that it is absolutely capable of building homes, reducing our carbon footprint and also helping save the planet.